Hello everyone, welcome back to the chapter 1 for General Maths Year 12. So today we're going to talk about 60, 95, and 99.7% of the root and also the z-scores. So why are we using the special numbers here? So what we do is set of the data approximately is a symmetric, looks like the mountains, and it's called the bell shape. So if you had a bell shape, that's the how you start with the normal distribution. Examples like birth weight and people's height, so which is like um, normally the distributions there they're symmetrical. So the height is getting higher, and the people will be not many. And also this is the generation looks like, for example. Uh, so what we do is we have some like figures. So we have figure 1 to 3. So 68 of the data between is a one standard deviation below. So which is like using your mean to minus the standard deviation. Um, and the 95, which is like they have a two standard deviation of the mean. So which is the below is the mean is bar x and minus 2s. So and a value of 2, which is standard deviation above the mean, so which is like basically you can say from the lines to lines, there's one standard deviation between. Here is become two standard deviation between. Later on, we have a three standard deviation. So 99.7% of the data is actually means three standard deviation of the mean. Yeah, so hopefully I want you guys to manage these things to your band reference and with these graphs, and that would be great. So some examples here. Hopefully I can help you guys. So you can see this is a pretty nice. Looks like the distribution, the normal distribution. The mean of the set is data is the 17.7. The standard deviation is 0.9, so s equal to 0.9. So what we do is we're gonna find out the 68 group line. So which is we have the one standard deviation. So which is we can try to calculate it. So question A. So we're using the mean minus s, which is the 17.7 minus 0.9, that equal to 16.8, and one standard deviation plus this the mean equal to uh, 18.6. So approximately, so we can say so approximately uh, 68% of the people will have a risk size between 16.8 centimeter and 18.6 centimeter. Yep. So that's the whole the answer. Um, Another one will be 95. So we do 95 is the two standard deviation mean, so which is minus 2s. That will be equal to 17.7 minus 2 times 0.9. So which is 0.1, so 1.8. So what we do is 77 minus 1.8 equal to 15.9. And I mean, please use the calculator. Okay, so you if you can't calculate it, just use the calculator. That's nothing wrong with that. So, and now what we equal to uh, is 19.5 actually. Sorry, see that I made a mistake by hand. So if you double check it, that'll be good. And then what we do is so approximately of the 95%. So we say 95% of the people will be start uh, from 15.9 centimeter to 19.5. Yeah. So 99.7 you can say is a 3 standard deviation, so we can find out by ourselves. Um, so hopefully that makes sense. Um, Next question, which is the distribution of mass, the packets, which is we have breakfast, the cereals, and then the bell-shaped rucksack. The main is 250 gram. S is equal to 5 gram. And then now we say less than 260. So less than 260. What we do is let's have a look. So calculate the percentage of. So once you have the question like this one, what we could do is uh, we find out 260. So we say 250 plus 2 times 5 is 260 grams. So that's basically mean plus 2 standard deviation, which is that's 90. That's a 2 standard deviation, which is uh, 2 standard deviation, which is uh, 13.5 plus and plus together. So will be 0.15% plus 2.35% plus 13.5% plus 68% plus 13.5% plus that's it. And then equal to 97.5%. Yeah, perfect. Mm, so now we say it's mass of the 245 is 1 standard deviation below of the mean. So which is around here. So what we do is we're using 245, which is give me a second, have a look. Less than 245. Let's say the mean minus the s, that will be equal to 245 grams. So which is here. So we're adding those three together. That will be 0.15 plus 2.35 plus 13.5, and that equal to 16%. Yeah, or we can use the 50 minus 34%. That's the other way to do. 240. So now 240, which is below the 2 standard deviation, which is only 2. Um, so it's below the main percentage. Um, so let's see how we go with. Um, if you have more than 240, which is you adding those numbers together again, and then that will be 97.5 again. That's a C. And between 240 to 255, which is from 2 standard deviation and to 1 standard deviation above. So 240 is more than 240, which is here, for example, to 255, which is 2 standard deviation of here. So you're gonna adding them, which is that one together. and that will be equal to 81.5% of the data. Yeah, so that's how you understand. Now we're going to talk about the stand of the z-scores. So z-scores, which is counting as how many standard deviation you had. So you have a negative and a positive. The numbers of the standard deviation, which is they are getting higher. For example, the formula to calculate the z-score, which is using the numbers the score minus the mean and divided by the standard deviation. Yeah. So the score 82 in the physics exam and 78 in her chemistry exam. In physics will be 62. So it's a 82 score the physics, 78 score in the exam in the chemistry. Physics, let's have a look. We're gonna find out the z score. Z score equal to z score equal to s minus the mean divided by s. So which is we know for physics will be 10 sorry will be 82 minus 62 divided by 10. So that will be equal to 2. So that means the z score is 2. And for chemistry, it will be equal to 78 minus the 66 divided by 5. So that will be equal to 2.4. So the chemistry, the result is better. Is actually better because of z score are higher. Okay, so which is that's how you say. Doesn't matter if you got 82 for physics, because you're managing half the rank looks like. It's it's not just your scores. It's more like the whole classroom scores, and then this is how you're gonna try to. Well, this is how you actually try to find out your ranking and also who did better and which one is higher. And this is using Z-score. And I will show you some question later as well. Hopefully that makes sense. And that's it. That's all chapter 1 and about data statistics. And